Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Your family, your community, your country, your responsibility. Be the best citizen you can be. Click on the Leader Say banner on this website to find out about your rights and responsibility.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
Yes, our lines are open for you. Chris Smith is with us on 021 446 0567 011 883 0702. Are you curious about the world in which we live? And do you want to find out more about the weird and wonderful laws of nature? So this is it. This is your moment. Give us a call. 021 446 0567 011 883 0702. Chris, nice to chat to you again. Welcome.
Morning, Rudy.
Hi there. So now this battery, can I use it to give me more energy because I'm so fatigued?
Do you know, that makes two of us. The battery you're referring to is a bendy battery or a stretchable battery, which has been produced by scientists in America. This is John Rogers and his colleagues in the University of Illinois. And you might say a bendy battery sounds a bit of a stretch of the imagination, but it's absolutely true. You can take this sheet of material and you can stretch it by 300%. In other words, make it 3 times bigger in any direction, and it will ping back to its starting shape when you let it go. But all the time it's being stretched, and after it's been stretched, it continues to work absolutely fine. And why this is important is that we can now begin to use this sort of technology and what it will turn into to provide power for flexible devices, which means we're not going to see our devices being constrained and confined in terms of their shape and their texture and what you can do with them by the batteries they have. So how have they done it? Well, they've taken lots of little tiny cells, lithium cells, that are 2mm discs. They've sandwiched them inside a stretchy sheet of silicone, and they have connected each of the discs with these little tiny pieces of wire that are shaped like a letter S. And the letter S wires are themselves what are called shape similar. So if you zoom in with a microscope, you see that each letter S is itself made of lots of little letter S's. Why this funny configuration? Well, when you stretch the battery, you're not actually stretching the tiny 2mm lithium discs. What you're doing is unfurling those wires temporarily, because there's a very big reserve of metal in the S shape, and this means that you can stretch the object in any direction and the wires just unwind for a bit. And this means that it can then ping back to its starting shape, and the amount of energy they got out of it was very respectable, about 1.1 milliamp hours per centimetre squared, so it's a good charge density, and it seems to have a reasonable lifetime. They've tested it over 20 charge-discharge cycles, and it seems to be okay. But obviously this is only the beginning, and they've now got to optimise this, and then we can have all kinds of possible things you could do with it. You could use it for implantable electrodes. You could wire these things into clothing, so you could have power on the move, and it wouldn't mind being deformed or washed. Don't know about ironed. We'd have to find out about that. And possibly other internal applications as well.
Okay, I've got an SMS here. Let me just summarize it. I think the person wants to know, why is it that when it is cloudy and rainy, bones that were fractured previously are very painful, or any injury for that matter? So does the weather, the temperature, affect our sense of pain stemming from an injury?
People often say this, don't they, that certain types of weather bring out rheumatism or make arthritis worse. I think that there's maybe a grain of truth, but mostly it's folklore. Now, what might the truth be? Well, certain weather conditions are certainly going to make certain living conditions unpleasant. And bony problems and joint pains are going to be worse when people are stiff. When you have bad joints, they tend to be worse when you have overworked them or first thing in the morning, before you've worked them, and then there's a good time during the day when you sort of loosen up a little bit. And if it's very, very cold, people can feel sluggish, and they can find that their joints are stiffer first thing, and it may take them longer to warm up and get going. So I can only think that a cloudy, rainy day may also be a cooler day, or the sort of conditions aren't ideal, and as a result people don't feel as good and they don't move as much, so their joints do feel stiffer. But I haven't seen any really good evidence showing that someone's done a proper clinical trial linking rain and cloud with joint flare-ups.
Our lines are open for you. Let's go straight to them. Brian, you're calling us from Observatory in Cape Town. Good morning.
Yes, good morning. I'd just like to ask, I've recently had the pleasure of meeting a very beautiful religious lady, and I'm not very religious, and she believes in Noah's Ark, and I very much don't believe in Noah's Ark, and she claims that there's lots of proof of the fact that the Great Flood did happen. Could I get the naked scientist's comment?
Hello, Brian.
Right.
I have heard somewhere that there are quite good evidence, there is quite good evidence for there having been some kind of flood at around the right sort of time frame when Noah's Ark is supposed to have been built and floated. I don't know any more than that, though, I'm afraid. I can't remember. It was a really long time ago. I just remember reading a little paragraph in a journal somewhere or, in a magazine. And the thing is, stories like this are so tempting for people to embellish or just sort of make up sometimes that really iffy. So if it's okay with you, I'd prefer to say I don't know, and I'll go and take a look and see if I can find that little mention. But there are certainly evidences of very, very big floods that have happened to very large areas in the past. And we can still see those floods written into the geology that's around today. So it shouldn't be too difficult for me to find out whether or not there have been some events historically in geological time, maybe going back a couple of thousand years, a few thousand years, and we can see what I can flush out, if you excuse the watery pun.
Our lines remain open, 021 446 0567, 011 883 0702. I've got an email here from somebody who's considering gastric bypass as a way to solve obesity. And she wants to know, does this mean that she will never ever get fat regardless of how much she eats, and what actually happens when a gastric bypass is performed?
Okay, so there are a number of procedures that can be done. One of them is a gastric band, and what this involves is hiving off a large proportion of the stomach so that it can't be filled with food. And this means that you feel fuller very quickly, and that has the effect of causing the stomach to release various I'm full signals into the bloodstream and into the nervous system via the vagus nerve, which tell the brain turn off the eating stimulus. A more radical approach is actually to remove stomach tissue and then to bypass a chunk of the intestine so that the area of intestine available for absorption of calories is restricted. And this means that then people don't absorb as many calories as they eat, and this should make it easier to lose weight. There are also other subsequent hormonal changes when you do this by removing some of the stomach, which reduce appetite. Now, I'm not clear, and I don't know if we know exactly why this works, but it does lead to a fairly substantial weight loss. The thing is that it's not without side effects, because if you reduce the absorption area in your intestine, what goes in must come out. And when it comes out, if it is not digested properly, it's not very pleasant. And sometimes if you eat a lot of fat, for example, and you don't break the fat down, then the fat has to come out again, and it comes out in a fairly unpleasant way. So there is no free lunch, another bad pun, I'm afraid, in this situation. But for people who do have morbid obesity and really do struggle to keep the weight off, then having something like this done to help them get their weight under control means they then can get more active, and staying active and being physically active is a really good way to keep fit and weight under control. And sometimes it's the catalyst that helps people get their life back in control and get control of their weight, where previously it controlled them.
Here. Is it Jackie in Parkview? Hi. Hello?
Hi there, can you hear me?
Yes.
Yes.
Carry on, please. You phoned us. You have a question for the Naked Scientist?
Yes. My mother is a chef, and she swears that leaving chef's knives lying in the water in a sink will blunt the blades. And my husband will not believe her, and there's a family feud going on. Is it likely that can water blunt sharp knives?
Okay.
Hello, Jackie. Oh, I'm sorry to hear about that. Make sure no one does anything nasty with those knives when they get angry and heated in this argument. Well, here would be my thought, which is that when the knife is sitting in the water, if it's just sitting in water and it hasn't gone rusty, let's assume they're really high quality knives, they're not going to go rusty, then the water alone is not going to dull the blade. But very few people leave a knife in water in isolation. And what blunts knives is when that nice sharp edge hits something as hard and sharp as it is, like other cutlery or other lumps of metal or stuff people chuck into the washing up as well. So if the knife just sat there on its own, I don't think that a bit of water is going to make a lot of difference to the edge or keenness of the blade. But dump a whole load of knives in there together and jangle everything round together, and things are going to hit that nice sharp edge, and which are as hard as it is, they're going to put little dents and lesions in the blade, and it will eventually go blunt.
Thank you very much, Jackie. And let's take a break. Trevor and Anne, I see your calls. We'll be back in a moment. 021 446 0567 011 883 0702, and we are taking your calls for The Naked Scientist. Let's go to Anne in Vanderbilt Park. Hi.
Hello.
Yes, hello, Anne.
Good morning. Look, I just want to know why when shipwrecks are discovered deep down in the water, they'll find leather shoes, etc., but very seldom skeletons. Is there any reason for that?
Okay. No
Hello,
skeletons, yeah?
Okay, I don't know the answer for sure, but I'm going to speculate. There's a number of reasons. One is that humans, when ships start to go down, tend to try and run off and may jump overboard. They may get into lifeboats and things, and so crews very often don't go down with the ship. Sometimes they do if they've been injured in the process or trapped below, but very often people do try to escape, and so the boat goes down without the people but with all the nice stuff on board. Also, sometimes when boats do go down and the people are accessible but dead on board, then other animals can make a meal of them, and that means that they tend to sort of churn things up a bit, eat all the soft bits, and then water currents and water movements and bigger animals can move around the bones and they get scattered or carted off. So those would be my two guesses. I think that's probably about all I can think of. If anyone else can think of anything, then do please let us know. But good question, Anne. Thanks.
Yes, please. Trevor in Nopislachte. Good morning to you.
Morning. Chris, I'd like to know, if you look at a cat or a dog's ear, on the lower or the outer edge of a cat or a dog's ear, there's like a little double flap in the cartilage. But if you look at a horse or a cow, there isn't that flap. Now, firstly, I'd like to know, what is that flap for? And secondly, is this a herbivore, carnivore issue?
Ooh, so just describe for me again, Trevor, because I'm not quite sure I know where that flap is. I'm just picturing my wife's couple of cats. Where is this flap of skin?
If you look at an animal face on, a cat face on the outer side of the ear at the bottom end, there's like a little double flap in the cartilage. It's almost like a little envelope in the cartilage on the edge.
Okay.
Okay, and it's like a little gap.
If you look at a horse or a cow, it's not there.
It's not there, yeah. And I've often wondered, firstly, what is the purpose of that flap? And secondly, is it a herbivore carnivore thing? I mean, I've only got horses and dogs and cows as reference, but I haven't noticed it on those two. So I was just curious.
I don't know, Trevor. Can you send me a picture? Can you go and find a really big lion or a leopard and take a photo really close up of its ears, if it'll let you, and then send that to me? No, I'm just kidding. No, if you do have any pictures, if you do have any pictures, do email me the picture to chris@nakedscientist.com.
Okay,
I'll take
a picture of my horse and my dog. I mean, you'll see it quite clearly.
Yeah, well, that'd be quite good to have a look at. I can only speculate that it's something to do with the way in which these animals move their ears around. I think dogs are slightly different because different breeds of dogs either have pointy up ears or floppy ears, like Labradors, don't they? But it might be something to do with the way these animals move their ears. Unlike us, they have quite intense innervation of the muscles around their ears, so they can move their ears around to get directional or facilitate directional hearing. And it may be that predatory animals like cats, as you speculate, have much better directional hearing capacity to go and find things because they want to go and eat them, whereas big herbivores are less at risk. They're more likely to need to go and find things by just pointing their head in the right direction rather than the cats moving their ears around. It might be something like that, I don't know. But send me a picture and I'll see what I can find out. I'll ask a veterinary anthropologist or something. It wouldn't be an anthropologist, but the equivalent, you know what I mean.
Fascinating. I can't wait for the answer. Thanks, Trevor. Tori in Pretoria.
Hi, good morning.
Yes.
Morning, Chris. I'd like to know on our national grid in South Africa. We use 22,000 volts, 33, 44. Is there a certain reason why don't you use 45,000 volts or let's say 25,000 volts? I will listen on the radio.
Hello, Tori. Right, so when we transmit electricity and we want to transmit lots of electricity over relatively long distances, then you use a high voltage. And the reason for doing that is that if you have a nice high voltage, then because power, P, is V volts times I amps, if you increase the volts, V, then you can decrease the current, I, and still transmit the same power. And because the power is also proportional to I squared R, because you're just substituting from Ohm's law, then the lower the current, the lower your losses in the line. The losses are proportional to I squared, the current squared, so you get the current as low as possible. So many countries have very high voltage transmission systems to minimise the loss from the wire. The thing is that these transmission systems are very expensive to implement. A really big transformer that can step up voltage to thousands of volts and then step it down again for domestic use is really expensive and takes a long time to build and a long time to put in. And if you have a country which has got a setup based on a certain voltage, then having been using that voltage, you're going to use more of those transformers for that voltage, and it becomes a self-fulfilling prophecy that you use a certain infrastructure. If you then think, well, we'd like to change that now, you can see that there's a huge cost burden in re-implementing and re-engineering the whole system to run at a different voltage. So very often, whatever you started with begets what you finish with until someone decides to have a really radical overhaul, which is costly.
Thank you very much, Tori. I think it's Tori who asked the question. Yes, Sipho in Meadowlands. Hi.
Naked, Chris, I just want to know one thing. I know this sounds very silly. I mean, I'm very old, and this still bothers me. The years. We are now in the year 2013. And we had a BC, before Christ, and AD. And as far as we know, the Earth is 1 billion years old or whatever. And the human culture traces back to about 1 million years or two. Now, when did we start counting the years? And how did that come about? Who decided and what informed them, that this is where we start? So that we can know now that today is 2013 and it's the 5th or whatever of
okay, so if the Earth is billions of years old and mankind has been around for so many years, why are we only in 2013 now? Okay.
Yeah. Well, I think that's a really insightful and really important question, so thank you for asking it. The answer is that I think people have been counting days and years for years, because if you think how important it is to know, if you depend on the environment for your survival, and when the weather gets bad, it might kill you. You may have nothing to eat. On the other hand, if you know where to go when the weather's going to get bad and you can look out for the signs that the weather is going to change, you can migrate or move, and this means you'll have more food or less food accordingly, then actually being cognizant of the days passing and the seasons is going to make the difference to you of life or death. And so I think even though people may not have been writing down dates, they almost certainly would have been very well aware of the fact that time is passing and that the Earth has a cycle going back, I would say, thousands, if not those millions of years that you referred to. And animals have evolved to do this. If you look at the great migrations across Africa, for example, animals do this themselves. They don't know why they do it. They just know they do it, and it's wired into their DNA. So that being the case, I think we probably are very, very similar, and we just have learned to write and write things down and record things, and that becomes a sort of mental prop. But earlier on than we had writing, people, I think, would almost certainly have been paying a lot of attention to what the environment was doing and changing their behaviour accordingly. And it just so happens that once writing got invented and people started making the written equivalent of notches on the wall or whatever to record the days going by, we then had a date system. And I think it was the Romans. I think it's the Roman calendar that we use now. But before that, there would have been other calendar systems. They originally had the number of days in the year a little bit wrong in some of these early systems, so they had to change that because obviously the months were moving around the calendar over successive years, so they fixed that one. But that would be my speculation. But if anyone has another take on this, and South Africa has a lot of very bright people who are very good at this kind of question, so please do let me know, Chris at Naked Scientist, or you can tweet me at Naked Scientists, and I'll tell everybody else.
All right, and the website address for The Naked Scientists, it's www.thenakedscientists.com. Chris, we chat again next week?
All right, Reedy, thanks very much. See you soon.
Beautiful. And this conversation will be available as a podcast.